What's up, guys? Today we're going to be doing a little bit of an introduction to polynomials. So first of all, what is a polynomial? A polynomial is just a sum of a finite number of monomials. Now, what is a monomial? A monomial is just a singular term in the form ax to the power of n, where a is called the coefficient. N is called, well, it's just the exponent. You should know that if you're watching a video on polynomials. And the x is just the variable. So it's basically a sum of many different, or many of these things, or like things that are in the same form as this, like added together. So the general formula for a polynomial is, if we call a polynomial p, general formula for any polynomial is a sub n x to the power of n plus a sub n minus 1 x to the power of n minus 1 plus a sub 1 x to the power of 1 plus a sub 0 x to the power of 0. So yeah, now let's just unpack this formula a bit. So essentially, this thing here is called the subscript of a. Now, so if this is a subscript of a, like so is this, like all of those are subscripts, right? And what those tell you is, those just tell you which power of x they correspond to. So in this case, a sub n corresponds to x to the power of n. A sub n minus 1 corresponds to x to the power of minus 1. X to the power of n minus 1. It's just telling you which power of x this coefficient, or the coefficient being talked about, corresponds to. That's it. It's not very complicated. The coefficients in this case, they can be anything. Usually in the problem, in the problem statement, they will tell you like whether the coefficients are integers, real numbers, quotients, whatever. And they will usually write it in, well, okay, let's say we have a set A. And so essentially, we have a set A, and they will write something like a square brackets x to denote the set of all polynomials with coefficients inside set A. So for example, they may say r square bracket x inside. That's just the set of all polynomials with real coefficients. In the same way, this is just a set of all polynomials with integer coefficients, right? So yeah, but like if there are no restrictions set, then the coefficients can be anything. However, there are restrictions on the exponents of x. So essentially, for any exponent of x, it can be 0, as we see here, but it cannot be negative and it cannot be fractional. So it's essentially, the exponent can just be any non-negative integer that there is, right? So for example, something like this. This is not a polynomial. Why is that? Well, we have this thing, and that is the same as, well, 1 over x is just x to the power of minus 1. If you don't know that, just like go watch a video on exponent laws or something. But yeah, so that's the same as x to the power of minus 1, which is negative, therefore it's not a polynomial. Similarly, if we have something like this, if you have something like this, if you have something like this is not a polynomial, because we have this term over here, and that's the same as 8 times x to the power of a half. Yeah, anything square rooted is just that to the power of a half. A half is not an integer, so therefore this is not a polynomial. So those are the main things that, where are we? Here. Those are the main things that you need to know about polynomials. The variable here doesn't have to be an x, it can be y, z, q, r, a, or like usually isn't a, but it can be whatever you want. Like, it doesn't matter. It doesn't matter at all. So yeah, another very important thing is, well, when we look at polynomials, we are usually concerned with the leading term of that polynomial. Now, what the leading term is it's just the term that contains the largest power of x. Okay, so in this case, n is obviously bigger than n minus 1, which is bigger than 1, 0 in this case. So essentially, the degree of this polynomial is just n, because n is the largest power of x that there is. So, yeah, so let's look at some examples. If we have 16x, so 72, plus 13x, 64, plus 2x, 8, plus 17. So what's the degree of this polynomial? Well, if we look at each of these terms, we can see that, well, here is actually an x to the power of 0, because it's just, 17 is the same as 17 times 1, which is the same as 17 times x to the power of 0, since anything to the power of 0 is 1. So if we just look at each of these terms and we look at the exponents of x, which in this case is 72, 64, 8, and 0, we just pick the greatest one, that's 72. Therefore, the degree of this polynomial here, degree is just 72, right? Yeah, so essentially degree is just the largest power of x inside that polynomial, and you may be getting a bit confused because this thing here does not look very much like our general formula here. And to that, I would say you are very much right. However, a can be anything, including 0. And what's actually in between the, well, x to the power of 16, x to the power of 72, and 13x to the 64 is actually like a whole bunch of 0x to the power of 71, for example, would be straight after this, plus 0x to the power of 70 would be next. All the way down until 64. So essentially, we just don't include any of that because there's no point writing it because it has no effect on the polynomial. So yeah. In this case, for example, 16 would be a sub n. This would be 0 equals a sub n minus 1. This is a sub n minus 2. You get the idea. So yeah, we've covered degree of the polynomial, general formula for a polynomial, some notation, or some ways of expressing stuff like this stuff, and we've covered it what's not a polynomial, like this, and something like the fourth root of x plus 72 plus 72x plus 2. That would not be a polynomial because fourth root of x is the same as x to the power of a quarter, which, well, a quarter is our exponent, and that is not an integer because it's a fraction. So yeah, we've covered what's not a polynomial, some notation, general formula, and the degree. One last thing before I end the video is there are some special types of polynomials which, well, it's useful to know the names of these things. So one type of polynomial that we have is a plus b. This thing is called a binomial. Bi for 2 and nomial for I guess nomial is kind of like numbers. So it's like not really two numbers, but like two values which are added together, I guess. So that's a binomial. Something like this, something like a plus b plus c, that's a trinomial. You only really need to know up to there. A polynomial with a degree. Let's say we have a polynomial, let's call that polynomial p. If the degree, which we denote as just deg for degree of p, is equal to 2, we call that a quadratic, which you should already know. Quadratic. If it's 3, it's a cubic. If it's 4, it's a quartic. If it's 5, I think it's called like a quintic or something, but I don't think you don't really need to know it. So just knowing like this stuff is good. One other thing is that if we, let's go here. If we have a polynomial with like just a coefficient as 1. So let's say we just have like x is 72 plus 7 or so, just something like that. Anything like that. We call that a monic because the coefficient of the leading term is just 1. So for example, like x squared plus 7x minus 67, that's a monic because the coefficient of the leading term is 1. So it's like a 1 hidden behind this x squared here. Yeah, I'm gonna end the video there. That's gonna be our lesson for like introduction to polynomials. In the next one, we're gonna be looking more into the degree of polynomials. Hope you enjoyed. Bye bye.